We have already talked about functions and how we can use functions to achieve code reuse in any programming language. And in our example, we were providing scenarios for Swift. Now we're going to talk about closures. Now, closures are actually very similar to functions when it comes to achieving code reuse, but they are a very powerful means of actually passing reusable blocks of code to be executed by some other function, some other class, or some other struct, which you may not have even defined. And we're going to take a deeper look at closures in this video. One of the best resources on closures and any other documentation is, of course, Apple's documentation on Swift, so docs.swift.org. And as you would see for closure documentation, Swift documentation will start by talking about global and nested functions. Now, global functions are also closures. And the only difference between global function and closures is that global functions have a name and do not capture values. While nested functions, as you would have seen earlier, are closures that have a name and can capture values from the enclosing function. Closure expressions are basically unnamed. They do not have a name assigned to them, and they can capture values from the surrounding context. Don't worry about what that surrounding context is. We are going to get to it. But folks coming from different programming languages, you probably have used something very similar to closures in those programming languages already. If you're coming in from Objective-C background, you have used block statements. If you're coming from Java background, then you would have used anonymous functions and lambdas. So you may have some context of what closures are. And to demonstrate how closures actually work, let's first start with the syntax. The syntax of the closure looks like, okay, there is an enclosing block to indicate where the start and end of closure is. Then there are parameters that need to be defined, what the parameters of that closure are. And then there is a return type, if this closure is supposed to have a return type. And in between, after the in syntax comes in all the statements that need to be executed. Now, looking at this syntax, and let's go forward and write a function. Okay, I'm just going to write a function. Let's say do something, and it goes forward and returns you a string. And let's say it takes a parameter, first parameter, string, and then goes forward inside the function, says return, and it returns hello to whoever was the first parameter which was specified. Okay, very simple. But then we talked about function types. If we have to define the function type for this method, it will look something like do something, string, which is a data type, and the return type of string. If this function was not returning anything, then we would still show a return type, but we just use a return type of void. And now when we look at the syntax for closures, which is within the closing brackets, you have the parameters. Okay, so there are the parameters and there's a return type, which is present. It's very much like what we had function types defined or how we used function types in the past. And as we started going over the documentation, we talked about global functions, we talked about nested functions, and we identified the main difference between them is first the naming, and the second thing is ability to get parameters from the context, which nested functions already have, global functions do not. Now, in this example, to demonstrate the functionality of closures, we are going to take a struct, and it's a custom struct which we have defined, which represents students, and we'll have the student name, a Swift score, and a Kotlin score. And then we'll go forward and initialize those structs. I'm just initializing it 3 times. You can initialize it many number of times. You can just go forward and have more set of parameters. Okay, 4th parameter. And there's another student which is coming in. And I can go forward and define their Swift and Kotlin scores. Okay, could be anything. Then I go forward and add this force parameter to an array. So I'm maintaining an array of students. These are all the students that are learning in my institution. And each student has a name and has learned Swift as well as Kotlin. So they have a score which is available for both programming languages. Now I have a challenge. I want to sort these students while displaying. Now arrays provide the sorted function. So I'm just going to say students dot sorted because Swift actually has a function which is sort. Um, but the question now is that how is Swift going to sort them? Well, it's a custom type. It's not one of the predefined types like string, integers, float, doubles. It is a custom type. And the second thing is that now it has a bunch of parameters inside it. I have name, I have got a Swift score, I have the Kotlin score, and when I'm sorting, am I doing a alphanumeric sort on the name? Or I am actually sorting based on the Swift scores, or I'm sorting based on the Kotlin scores. What exactly am I sorting upon? And that becomes question, right? And Swift doesn't know what your custom types are and how to go about and sort on those custom types. So let's look at the definition of the sorted function which is provided by Swift. And all you have to do is press the Option key as you hover your mouse over the sorted function. You click on it and you get to the documentation. And of course, it provides you details about what it's trying to do. And what you see is that the sorted function accepts a predicate. And the predicate seems pretty straightforward. All it does is that it accepts the two elements. Basically, in our case, Swift has automatically been able to identify that we're using student, so it's providing the right context student. So it will take the two student elements, and when you do the comparison of two student elements that are passed, you're supposed to return back a Boolean. And the Boolean is going to tell us whether the first value is greater than the second value when sorted. Now again, I can have four elements, I can have hundred of elements. The syntax for the sorted by function remains the same. It's going to give you two elements from the array. It could, in our scenario, it was student struct. It could have been anything. It could have been a struct of bank accounts. It could have been a struct of email IDs. It could have been a class instead of being a struct, and the class could be of any type, like cars which are out there, whether it's a GM, it's a Ford, it's a Nissan. It could be any of those types. But all it's saying is that for the elements in this array, and arrays can be made of elements of the same type, for an element in this array, I'm going to pass you the two elements and you're going to tell me, is the first one greater than the second one or not? Okay, and by greater than and less than, I'm being very obscure. Means it's just trying to get the ordering and not really saying that okay, a score of 100 is greater than 95. If you think 95 is greater than 100, that's also fine. But based upon whatever logic you're following, is the first element supposed to be the first element as compared to second element? Now, yes, when I use the word compare, you could have used a comparable interface protocol, and you could have implemented a comparable protocol to actually do the comparison. But if you have not, like I did not had a comparable protocol for my student struct, then I can still go forward and sort them. I just need to tell how I'm sorting those two elements. So advantage of doing that is that uh, for sorting, there are a lot of efficient algorithms which are out there in the market. You should be using selection sort, bubble sort. You should be using recursive bubble sort, insertion sort, recursive insertion sort, merge sort, iterative merge sort, quick sort, or other sort algorithms. There are 10 available. But you don't need to worry about all those algorithms. How to do the sort is taken care for you by Swift. All you're doing is taking two elements and telling Swift here is which element comes first and which element comes second. And then Swift is going to iterate over your array and figure out how to get you the final sorted array in the most efficient order. So to do so, First, I decided to start with very simple process. I defined a global function. The global function is called sort students. Take the two elements, first student of type student, second student of type student. Returns a boolean, which is exactly what the sorting function needs. Then I simply go forward, and in this example, I simply go forward and compare the Kotlin scores and say that, okay, if the Kotlin score of the first student is greater than the second student, then it's true. The first element is supposed to come first, and the second element going to come second. Otherwise, it's false, which means reverse the elements. They are not ordered correctly. So I go forward and sorted by takes a predicate, and which is basically just like your closure statement. It's in the by, you are going to pass on the predicate information. Now, since I define a global function, all I do is that I pass the function name. So it's sort students, take first student and second student. I pass the function name in my sorted function. Now let's go forward and execute this. Okay, it's executing. Now let's look at the result. If we look at my original array, Alan was first, okay, and he had a Swift score of 100, okay, and Colin score of 25. Then Chrissy, Swift score of 25, Colin score of 100. Suzanne, Swift score 60, Colin score 60, and the fourth student, Swift score 35, and Colin score of 95. But I'm sorting based upon the Kotlin scores. And if I look at the Kotlin score, the highest Kotlin score is by Chrissy, and you can see in the eventual result, Chrissy comes to the top. Then the second highest score is by the fourth student, and the fourth comes second. Then Suzanne has the third highest score and the fourth highest score, so the sorting worked fine. Let's try and see what if my sorting algorithm was different. So I could have gone forward and said that, okay, if the first student Swift score is greater than the second student's Swift score, then that is the new algorithm that is I want to run. And if I go with this one, then Alan remains on the top because he has the highest Swift score. The second one should be Suzanne, which it is. Third one should be fourth student. And the last one should be Chrissy. And that's exactly what you see in the output result. So you can now totally appreciate the power of closures where um, Swift implemented the sorted function, took care of all the complications of what kind of sort algorithm that needs to be applied. It just doesn't know what your criteria of sort is. And the criteria of the sort is what you're supplying as predicate using your closures. And these are reusable blocks of code that you can pass around inside your code and have the different parts of the code execute the block of code or the logic that you wrote and then use that logic to make decisions. So again, it takes encapsulation and code reuse to the next level. You can, of course, as you can imagine, do a lot of things, and I will let you play around with those items. Again, the link to these playgrounds are available inside the comment section or the description of this video, but I will let you play around. You can actually even define more complicated logic inside your sort algorithm, which simply can go forward and say that, hey, instead of just looking at individual score, I'm going to look at the averages and who has the highest averages, the first student, right? This across. So you can average them up and then decide upon which one is greater, which one comes first and which one comes second. The important thing is that all you need to do is that you're comparing two students and telling me which one comes first and which one comes second by returning a Boolean. All good, sounds very powerful. Now, Swift is all about being concise and clarity. So let's see if we can actually go forward and simplify this. For example, I wrote this sort students, but I really don't need to reuse it anywhere. I wrote it specifically for this array and I'm sorting this array. So do I need to keep it here? Like, or anything else in this class is not going to call sort students or uses sort students. So why have it defined as a global function? And yes, you have a better way of doing it, and it's demonstrated here. Now, in here, what I did was, as compared to the previous example, where I was passing a function, I need to pass here a closure. And as you know, the closure syntax is you start with the braces, okay, and then you go forward, define the parameters, and define the return type, followed by n, and then you have your statements. And that's exactly I did. I'm going to go forward and say students dot sorted by. I start my starting and ending braces. I then go forward and define my parameters, which is first student and second student, and returns a boolean in. And then I have my normal conditional check, which is present, which is if student's first student score is greater, Kotlin score is greater than the second one, then it's true, otherwise it is false. And now you don't need a global function. Everything is contained in the sort call itself, and it makes sense because even from readability perspective, if there's a decision that you need to make on how this code needs to be sorted, then the decision is present here. You don't need to go anywhere else to figure out how the decisioning is actually being made. Um, but again, Swift, we know, provides very concise way of executing these things. So let's look at even if there is even more concise way of handling this. I'm printing sorted students here. I really didn't need it to print it. I can just say sorted students and I will be done. I can then expand them and actually see them, and I can see that, okay, fine, these numbers are actually sorted on the Kotlin score, so all good. But let's look at what else we can do to actually even reduce the code further. And if we want to actually reduce the code further, then we can simply go forward and drop this definition itself, which was identifying the parameters by named pairs, saying first student and second student. In the context of the sorted function, when you're calling sorted function and you call by, Swift has the definition already defined. Now, again, press the Option key, hover upon it, see the help. And as you see the help, you can see that, well, the by function is going to accept a closure, okay, which is going to accept the two elements and return a Boolean. So Swift knows that the only function type that you can pass is going to accept two elements of the array and then return a Boolean. So it cannot be anything else. So you can drop it, but if we drop the definition, the function type itself, then the problem which I have is that how do I refer to these input arguments which are supposed to have the elements which are supposed to be passed to me? And the way you can do it is that in Swift, if you drop the definition, then Swift still knows that there were two elements which were passed and they will be zero indexed for you. So you can refer to them as $0 and $1. $0 being the first element, $1 being the second element. And you can do the same exercise you were doing there with even lesser and more clearer piece of code, which simply states is that if the first element is greater than the first element, then keep the first element at the first position, otherwise move the second element to the first position. All good, and let's go forward and see. If I go forward and execute this piece of code, then what happens? I can expand my to see how the results look like, and the results are absolutely correct. Again, Chrissy still maintains the highest Kotlin score, and that's what you see. Chrissy at the top, followed by Suzanne, followed by Alan. All good. Now this is seems like very clear piece of code. Originally, we started with defining a global function and then using a global function. Now we are reduced to just a conditional check. So it seems all good. Can we do something more to this? And actually, you can. You can even go forward and make it more concise. So what I'm doing here is that since it's just accepting the closure, I can even go forward and drop the by name parameter. I don't need to to call that. All I will do is that I will say students are sorted, and I will start my closing brackets and just have the logic of checking the first student score with the second student score and just tell you whether the first element is supposed to be at the first position or not. And that's pretty much it. One thing people do find interesting is that when I am just having an enclosure or a closure block or predicate which is being passed, I basically go forward and not only drop the name parameter, I also drop the starting and the closing brackets. And yes, Swift allows you to do that, and it's a shorthand syntax where if you are just passing, and that's the important part, just passing a closure block, then you can drop it and just start with the block statement directly. So even more clearer, I now have sorted and I have starting with the starting curly braces, any curly braces in between. I have the logic of actually performing the sort, all good and dandy. Can it something be done? Actually, yes. We can even go forward and reduce this line of code now. I'm saying students are sorted. I'm starting with the starting bracket, ending bracket, and just having the return statement. A bunch of this was a bit irrelevant because all I was doing was comparing the Kotlin scores of the two elements and returning true and false. I don't need to have a if else kind of a block. I can just say return and I can just say, okay, if the Kotlin score is greater than the second Kotlin score, then single line. Now imagine how clear it is. There's no global function, nothing to do. I have an array which is present. On the array, I call the sorted function. And I am simply comparing two elements, which I'm identifying as $0 and $1, and returning if the first element is greater than the second element or not. And actually, we can go even further. If you have a single line of statement inside your sorted function, and all it's inside your closure block, and it's all it's doing is it has a single line of code, okay, and it has a return type, and then Swift is going to assume that that's what is supposed to be returned. So you can even drop the return keyword. So you can have students are sorted $0 Kotlin score is greater than Kotlin score, and you can go forward and print it. And Swift now knows that that's what you were trying to return. It's going to assume that's a return statement, and you can now go forward and see the results are the sorted array. So originally, where we started by having global function, then passing this that to the sorted function, then we had a big line of code when we're using closures, is reduced to a single line of code where you're saying students are sorted and you're just telling how it's sorted. You can still go forward and change it by saying that if $0 dot Kotlin score plus $0 dot Swift score is greater than, and for clarity, I'm adding these brackets, is greater than $1 Kotlin score plus $1 Swift score, then that's the sort that I want to use. I want to figure out is who has the maximum value which is present. And since I'm doing a greater than check, Alan still maintains the lead. So Alan remains the top, followed by Chrissy, followed by Susan. It maintains the same order. Could have put in a caveat here where I can have Alex come in and Alex having 80 in both of the values, and since Alex has 80 in the both values, when I go forward and add Alex to my array, now Alex has the highest score. He has scored 160. No one is coming near Alex because he can code in both programming languages. And you can see here is that your logic could be anything, but with closures, you can actually, first of all, remove the need of maintaining or defining global functions and then providing mechanism to have a callback to those functions someplace. You can actually pass reusable blocks of code as anonymous code blocks for execution by some other piece of code that you may have written or you may not have written. The sorted function was not written by us, sorted function was written by Apple. And we passed on our closure predicate, reusable block of code to Apple's function to tell them how to actually go about and do the sorting. And Apple was able to go and do the sort based upon the decisioning criteria that we have chosen, while Apple still takes control of the underlying algorithm which was used for actually doing the sort, whether it was bubble sort, selection sort, insertion sort, that's still not my problem. Still, Apple is handling that. I'm just telling them how to compare two elements in the array, and Apple takes care of handling the rest.